Right, guys, what we did in the last lesson, we looked at average gradients, and now what we're doing is we're going to get a general formula, which Nelson spoke about, the x plus h. Just have a look at a sheet of paper quickly here. We've got, to recap, we had this as point A here. This was point A there, and this was point B. Okay, and remember the distance between those 2 points. If you go from there to there, you actually were adding on a number called h, giving you that. Now, Nelson, what is the coordinates of A then? If that's x,
that will be x is x, then y is f of x.
Correct. Okay, and this is?
X plus h for x, and the y value is f of x plus h.
Correct. Okay, so we've got points A and points B. Now, if we go to the slide, okay, Nelson, take them through determining the gradient of this line joining the 2 points.
We already have the points, guys. Then we simply say y at B. The B point y there is actually f of x plus h minus f of x. And then the x value at B, if you remember, well, is x plus h. Then the x value at A is x. Remember, this minus is there on the formula. And it's a matter of simplifying the bottom. Then the top one stays the same as f of x plus h minus f of x. Then the bottom one, remember, x will cancel x. Then you have h. And this is now the general formula for the average gradient.
And the important thing, look at the sheet of paper here. It really is, guys, as Nelson pointed out here, it's the gradients of the line. So the gradient of AB is, remember, it's this guy. So you say that minus that, and then divided by this minus this, which gives you the formula fx plus h minus fx. We're going to use this thing. Remember, we've spoken about limits, and we've spoken about the average gradients as well. Now, those x's cancel, which gives you then this general formula. Let's just make sure you guys are fully aware of that. And there we go. Remember that you had it's that one minus that one over this minus this, and you have a formula for that. But now the excitement starts, Nelson. We're now going to do something very beautiful. Okay, now watch this. Let's go on. If we take our 2 points. Okay, now Nelson, watch here. We've got x. Okay, that's going to be h. Okay, now I am going to change this line. I'm going to move it down. In other words, what's now happening is that point B is getting closer to A. So the line's moving. Okay, now check this out. What can you tell me? What do you think is happening to the H? What's happening if that line moves?
If you get in this point closer to A, look, H was this distance, and now it gets smaller and smaller when you move this point closer to A.
It looks like the gradients, that average gradient, the gradients of the line is changing.
It's changing.
Okay, let's see what happens next.
Right.
Wow.
Until when you move this point onto A, you have A, what do you call this line mark?
It's a tangent.
This is a tangent.
A tangent line. Now look at this. What happens here?
Then it means H is approaching 0.
So what's happening is that
you're
line...
You're shortening that.
Absolutely. It's a line. If you take this ruler here, if you look at it, it's the line moving. The line moves, those 2 points move together, and H goes to 0. It looks like it's a kind of a limit.
Yeah.
Okay. Now, really, guys, this is quite a complicated thing. But Nelson, show them what the formula for the gradients, which we call from first principles, is. Check it out.
Right. Look at this, guys. Now, this is still what we call the average gradient. We talked about this. Okay. Because we're moving point B closer to point A. Now we have what we call the limit. Because we're moving. We're getting this distance close to 0. We're shortening that distance.
And that is called the gradient of the tangent.
Yes. The gradient at a point.
Yeah. And this is important. If you look at a sheet of paper quickly here, if you've got a curve, what we're really taking, there's a parabola. If you have a look at it at that point, there's the curve, but we've got a tangent. And the most amazing thing happens is the gradient of the tangent is the gradient of the curve. This is one of the greatest discoveries of Newton. I think it's amazing.
Yeah.
So Nelson, if we move on, what do you think here? Let's check it out. Look at that. We've got, what do we have?
A at that point.
Is
Then
a
the y
point.
value is f of A,
F of
obviously.
A, correct. That's the y value. Okay.
Right.
Now the gradient of the tangent is the gradient of the curve.
Yep.
And we use a new notation called f prime or f dashed.
Yeah.
What do you say?
Prime.
Do you say F
I go
prime?
for prime.
Yeah, dashed is a bit
Yeah.
funny. F prime is better.
Yeah.
And the symbol, if you have a look at this, if we go to a sheet of paper quickly, the important thing is F prime, if that's
Meaning
X,
the gradient at a point, guys.
gradient
of
it's
a
the
tangent.
Gradients. There's a whole lot of things. And if we go on, let's have a look. Nelson, there's FA is the y value at x equals a. That thing F prime A is the gradient of F at A. And symbols for gradients, that's F prime X, or you've got dy over dx. We'll comment, guys, we will come back to this. Dy dx and that. Okay, dx. And do you want to tell them other words for gradients?
Other words for gradient, guys, look at this. We call it the slope of course from grade 10. And the derivative, we're going to use this. We'll talk much about this
Much about
in the
the word
next
derivative,
lesson.
yes.
Derivative. And you may also call it rate of change. This is very important as well.
Very important. The essence, the gradient of the tangent to the curve is the actual gradient, derivative, slope, rate of change of the curve. And Nelson says at the point, not the average gradient.
Yeah.
Watch the space. We're coming back with some more juicy gradient from first principles.